Welcome to College Prep Chemistry. You are watching this video because you are enrolled in the College Prep Chemistry course at Lake Mills High School. Throughout the course of the semester, you will watch a series of videos that will instruct you on how it is that we go about doing chemistry. As we watch this first video of the course, I will point out different features of each video to pay attention to help you in your learning, and some things that you want to look for on each slide that can make your learning more efficient. So our first unit is entitled Tools of Chemistry. And our first video in our Tools of Chemistry unit is on the subject of dimensional analysis. So for any video that you watch, there will always be at least one standard and learning target for which it is focused. Typically it will just be a single standard and often more than one learning target, and that is the case here. Our standard for this video, and it is the essential standard for our first unit, Tools of Chemistry, it is I can use proportional reasoning through the use of dimensional analysis to solve problems. And the learning targets that are associated with this standard are as follows. We need to be able to describe conversion factors and how they can be used to convert units. We want to be able to use prefixes in the SI system to convert units. And finally, we want to be able to use dimensional analysis to solve problems. This particular lesson will focus on the first and third learning targets in this standard. Our next video will take a look at the second. So jumping right in here, we want to be able to describe conversion factors and how they can be used to convert units. So as I click to the next page here, you'll notice at the top I have listed the learning target that we're working on at this point. This is a quick reference for you. So as you're watching this video, or if you're looking at the PowerPoints that you've accessed on the Google Drive folder, you can look at the top and you can quickly see which learning target we're focusing on. So I've asked a question here on this slide, what is a conversion factor? And we're not going to answer that question just yet, not immediately. We're going to look at a problem that you might think, well, I could do this. I don't really need to know what a conversion factor is to do this. But the fact of the matter is if you complete this problem correctly, even though you don't know it, you are using a conversion factor. So we'll look at why that is and how we use these conversion factors. So the question, a table measures 152 inches long. How many feet is this? So boiling the question down to the absolute minimum details here, we want to know how many feet, so question mark feet, are equal to 152 inches. Now you're probably thinking, well, I know that there's 1 foot in 12 inches. Those are the same thing. In other words, I could write that as an equality here. 1 foot equals 12 inches. And you might be thinking, well, all I have to do is take 152 divided by 12 and I got my answer. And you would be right. That would give you the number of feet that table is as far as its length, but we want to explore why that is and how this relates to this idea of a conversion factor. So a conversion factor is any equality, and when I say equality, that's something with an equal sign in it, like 1 foot equals 12 inches. It's any equality written as a fraction. So you might be wondering, well, how can I write an equality as a fraction? Well, I'm going to show you how. And we'll start with a more simple example here. So why write it as a fraction? Well, the reason is because it will have a value of 1. If you're not convinced by that, let me show you. So let's consider this equality. Simply the equality 7 is equal to 7. Now I've put a subscript A and B next to each of these numeral 7s just so we can differentiate between the two. That's the only reason they are there. So this is not indicating 7 times A or 7 times B. It's just so that we can differentiate between one 7 or the other. If I take that equality, 7 equals 7, and I write it as a fraction, 7 divided by 7, and in this case I've gone the A version over the B version, that's going to equal 1. Because 7 is the same thing as 7. Anything divided by itself will equal 1. Likewise, I could have written the second 7, the one I had labeled 7b. I could write that one divided by 7, and 7a, the first version, and again that would equal 1 because anything divided by itself is 1. Let's apply that thinking to this equality we have up here, the 1 foot equals 12 inches. if I take 1 foot and divide it by 12 inches, even though it doesn't really look like it, that will equal 1. You might be thinking, wait, 1 divided by 12 doesn't equal 1. And you're right. If it's simply the number 1 divided by the number of 12, that would not equal 1. But these two values here are not simply numbers, they are a quantity. The quantity 1 foot is exactly the same as the quantity 12 inches. So 1 foot divided by 12 inches equals 1. Likewise, I could do it the other way, where I do 12 inches divided by 1 foot. That would also equal 1. So what we've done is we've taken this equality of 1 foot equals 12 inches, and we've turned it into a conversion factor. Both of these fractions we have written here, 1 foot divided by 12 inches, or 12 inches divided by 1 foot, those fractions, they are both considered conversion factors because they are fractions equal to 1. So summarizing our problem so far, we're looking for how many feet are equal to 152 inches, and we've identified this equality, 1 foot equal to 12 inches, is important, and these are the conversion factors we can get from that equality. So the question I have for you now is, what happens when you multiply any value by the number 1? So just pick any number you want to, multiply it by the number 1, what are you going to get? Well, of course, you're not going to change the value. You're going to get whatever you started with. Multiplying by the number 1 never changes the value of the quantity. So the point is if we want to convert from one unit to another, as we are here, we're going to convert from the unit inches to the unit feet. We're going to multiply by a conversion factor because that conversion factor equals 1. When we ask ourselves how many feet long is this table, this length that we give should not be any longer or shorter than the measurement in inches. Just because I measure it in inches one time and feet another time doesn't mean the table should get any longer or shorter. The value must stay the same. So, starting with this question that we have, how many feet equals 152 inches, I'm just going to take this quantity 152 inches and I'm going to multiply by one of these conversion factors. Now you might be wondering which one. I could multiply it by the first one, where I have 1 foot over 12 inches, or I could multiply it by the second one, where I have 12 inches over 1 foot. These fractions that I've multiplied by are both equal to 1. So the question is, which one is correct? Or maybe the answer is they're both correct, because again, both these cases I'm multiplying by 1, so I'm not changing the value. Well, the secret is this. You must look at the units. Do the units that we get, do they match what we're looking for? Well, in both cases, I want to get feet. How many feet is equal to 152 inches? Well, in this first one, it's going to work out very nicely because notice my inches unit cancel. This inches here in the 152 inches is in the numerator. This inches is my conversion factors in the denominator, so they cancel. And notice I'm left with the unit feet, which is exactly what I want. So that conversion factor is actually the one I want to use here. So I would just plug this in my calculator now. I'd have 152 times the fraction 1/12, or simply you could type in 152 divided by 12 into your calculator, which recall that's what we initially said we wanted to do anyway, and you're going to get 12.7 feet. The second way, while the value would still be correct, my units are not going to make any sense. Notice that my inches unit do not cancel. They're both in the numerator. So inches times inches is inches squared. I still have this feet in the denominator, so that's inches squared per feet. That does not match the unit I'm looking for, certainly. So that unit's nonsensical, and I would not want to use that conversion factor. So the moral of the story is this. We want to use the conversion factor that will give the unit that we're looking for. So we must check the units each time. Let's look at another example here. Determine the number of inches in 0.65 miles. And I tell you here that there are 5,280 feet in 1 mile. You may not have known that off the top of your head, so just throwing that out there. So summarizing what it is we're looking for, I want to know how many inches, question mark inches, is equal to 0.65 miles. Now as we do this, I want to identify possible conversion factors or equalities that I might need. Well, we're straight up told in this particular question that 5,280 feet equals 1 mile, But that's not the only equality I'm going to need, because I also need to get inches into my problem somehow. Well, thinking about the last problem, I know 1 foot is equal to 12 inches. And so notice I can relate these two equalities together because they both have the unit feet. I have inches in there, which is what I'm looking for. I have miles in this first equality, that's what I'm starting with. So I should be able to do this with those equalities. So now we're going to see that oftentimes when we use conversion factors, we need more than one. So in the previous example, we just needed that one conversion factor or equality, 12 inches equals 1 foot. Here we're going to need two. And we can do it all in one problem. We don't have to do one problem and figure out an answer and then use the other conversion factor. We can just do it all at once, makes it very easy. And here's how. So starting with our question, how many inches are equal to 0.65 miles, ask ourselves, what do I want to cancel? What unit do I want to get rid of? Well, I want to get rid of miles because eventually I want to make it to inches. So if I look at my equalities, I can see this first equality, that's the one I want to use as a conversion factor because it has miles in it. And I can see I want that miles to go in the denominator, the bottom of the fraction, so that it cancels with the original miles unit that I have. So I have 5,280 feet over 1 mile, and notice my miles unit cancel. Now if I just stopped here and did this calculation, which we could, but we don't really need to, that would tell me how many feet are in 0.65 miles. But that's not what the question asks. We want to know how many inches. Now you could plug this in your calculator and figure out how many feet there are and then write that number down and then do another problem to find out how many inches that is. But that's kind of a waste of time. Plus it leads to more errors because we have to plug more stuff in the calculator. So I'm just going to keep going with my conversion factors here. Notice now I need feet to cancel. So if I look up here at my equalities, I'm going to use this second one that we wrote, and I'm going to put the unit feet in the denominator, the bottom, so that the feet units will cancel. And notice what we're left with now. I'm looking for the unit inches. All of my units in my problem have canceled with the exception of inches, so my units work. It means we probably did it right. Just a matter of plugging this into our calculator now. So we're going to take 0.65 times 5,280. You could hit divided by 1. Obviously, that's not going to change anything. Dividing by 1 is still going to give you the same value. Then you'll multiply that by 12. You don't need to hit equals in between. So in other words, all you're going to hit is 0.65 times 5,280 times 12, and that's going to give you your answer. And you should get 41,000 inches. Now you might be wondering, but wait, my calculator doesn't say 41,000. It's something kind of close, but I've rounded it here in the example, and I have rounded it. The reason is, and we'll learn these very shortly, there are specific rules for teaching us where to round all of these calculations with these measurements. So needless to say, we would end up rounding this one to 41,000. At this point, you don't need to be concerned about why that is. We just want to make sure we're doing these conversion factors correctly. So to summarize here, and it's leading us into the title of this video, the dimensional analysis. Dimensional analysis is simply a problem-solving method of multiplying a known quantity. So in this case, our known quantity was the 0.65 miles. By one or more conversion factors, so here we multiplied by 2 conversion factors to obtain or to determine an unknown quantity. In this case, our unknown quantity was the number of inches. That's what we were looking for. That, ladies and gentlemen, is dimensional analysis. Just take what you know, multiply by a series, or sometimes it's just one conversion factor, but often a series of conversion factors, making sure that your units work the way you want them to, and you get your answer. So a few review questions here. As each question pops up, read it, pause the video, answer it yourself, and then continue with the video to see if your answer matches or closely matches what I have written. Question number 1. What is a conversion factor? A conversion factor is an equality written as a fraction. Like for example, 12 inches equals 1 foot. We can write that as a fraction and we have a conversion factor. Question 2. What is the value of a conversion factor? A conversion factor is a quantity always equal to 1. Question number 3. How do you use a conversion factor to convert a unit? And also, what is the significance of the conversion factor being equal to 1? So to use a conversion factor, we simply multiply a known quantity by the conversion factor that we are using. And then the significance of the conversion factor being equal to 1 is that it does not change the value of that measurement or quantity. We can multiply by as many conversion factors as we want. Because those conversion factors are fractions equal to 1, we do not change the value of that measurement. Last review question. How do you know which conversion factor to use? You need to use the conversion factor that gives you the units you are looking for after the canceling. So make sure that your units cancel along the way as you plug in those conversion factors to get the unit that you want at the end. And we will certainly see more examples of it here. So taking a look here at our standards and learning targets, we have described conversion factors and how they can be used to convert units. As I mentioned previously, we're going to skip over that second learning target there. We'll hit that one up in the next video. We're just going to look at some more examples here of how we use dimensional analysis to solve problems. So jumping right into a problem here, we'll just work through this one together. You work a part-time job and earn $9.55 per hour. How much money will you make if you work for 952 minutes? So anytime we want to use dimensional analysis, we just want to summarize the problem where we ask ourselves, what are we looking for? In other words, what units should we have when all is said and done? And then what data or what information do we have to start with that we already know? What is our known quantity? Well, here, this is what we're looking for. We're looking for money. How much money? So question mark dollars, that's what we're trying to find. How many dollars will we make if we work for 952 minutes? So 952 minutes, that's our known quantity. Along with this, we also want to identify any conversion factors or equalities we might need. Well, if I look back at the question, this information about our wage, that's an equality. Even though it's not written as such, what that means is that we make $9.55. That $9.55 is equal to 1 hour. So for every hour of work, that's equal to $9.55. So there is our, at least a conversion factor. You'll also notice that our time units in the problem were given minutes of work, yet our wage is measured per hour. So we're going to need to relate those two units. And of course, 60 minutes is equal to 1 hour. So there's another equality we might need. So now it's just a matter of matching up our units with our conversion factors and canceling the units that we don't want. So we've identified possible conversion factors, equalities. That's what we've written here. So now let's see if we can get these units to cancel. So the first thing I see, I want to get rid of minutes. If I look at my equalities that I've written, this second equality contains minutes. So I'll use that one as a conversion factor. Notice I want minutes to go in the denominator, so it will cancel with the minutes in the numerator as I started with. So minutes cancel. And now I need to cancel hours because I want to get rid of hours and get to dollars. Well, now I can use that first equality that we wrote. So I want hours to go on bottom. So 1 hour on bottom. And notice I didn't actually explicitly write in the numbers 1 here next to hours. Anytime there's not a number there, we know it is 1. And notice as I have it written, I have an hour in the numerator, hour in the denominator. So hours cancel. And notice my units that I'm left with are now dollars, which is what we want. So we've multiplied by the conversion factors to cancel our units. And we do, in fact, I'm looking for dollars. I get dollars. That's all that's left. Check your units every single time. This is so important when doing this dimensional analysis. Check those units every single time to make sure that you have the right ones that you're looking for. So now it's just a matter of solving it and plugging it in our calculator, getting an answer. And if we do that, when we plug this in, we're going to take 952. I could hit times 1, but no, that's not going to change anything. Divided by 60, because 60 is in the denominator, and then times 9.55. And then I could hit divided by 1 if I wanted to. Again, it's not going to change anything. The moral of the story there is if the number is in the denominator, you divide. So 952 divided by 60 times 9.55. And in this case, we will get $152 for our work. And so we have answered the question, $152. Alright, here's a practice problem. So the practice problems, how you do these is you read the problem here, pause the video, try to work the entire problem on your own. Once you get done, then play the video. And if you made it all the way through the problem, you can probably skip through this screen pretty quickly. Make sure you get the right answer, of course. If you get stuck, though, as you're solving the problem, play the video, watch how I do it, listen to my comments, and that will help you out. So suppose you drive a car that gets an average gas mileage of 18.6 miles per gallon. If the cost of gasoline is $2.56 per gallon, how much money will the gasoline cost you to drive your car 525 miles? So as always, we want to identify what are the units we're looking for, what do we want our answer to be, and then what data are we given, what is the known quantity to start with. So we want to know how much money. So like the last problem, our units are going to be dollars. How many dollars are going to be equal to, well, in this case, I want to know how much money it takes us to drive 525 miles. So I know to start there. Sometimes it can be kind of difficult to figure out where to start because I look at the problem and I see all these numbers here. It can get a bit overwhelming at times, but if you really just focus on what the question is asking you, how much money will it cost you to drive 525 miles? That's your known quantity, the 525 miles. So now we want to identify possible equalities to use. Well, if I look at the problem, I can see there are actually two equalities that I'm given. One of them is 18.6 miles equals 1 gallon of gasoline because we get 18.6 miles per gallon. And the other one is $2.56 equals 1 gallon of gasoline because that's the cost of our gasoline. And looking at the units here, I'm starting with miles. I can see I'll be able to cancel miles, and then I need to go from gallons to dollars. Looks like I'll be able to do that. So I think that's all I'm going to need. So now it's just a matter of getting our units to match up. So notice our miles will need to be canceled first. So I'm going to use this first equality to start with, and I'm going to put the miles in the denominator. So 18.6 miles on bottom, 1 gallon on top. Notice your miles cancel. And now I need gallons to cancel, and that will get me to dollars if I use this second equality here. I put my 1 gallon on bottom, my $2.56 on top, gallons cancel, and now I check my units and notice I'm looking for dollars, and I have dollars left over. I probably did it correctly, just a matter of solving it with our numbers now, plugging it in your calculator, and you should get $72.30 roughly. Again, there are rules for knowing where to round. That's why it looks kind of funny. I just have the $72.3. We'll learn about those later, though. All right, another practice problem, and this one is a little more advanced. So as you read it to start with, you may get stuck initially. So you might want to play the video, see how I start it. And then once you kind of see how I've started it, then pause it, try it yourself, and see if you can get the same answer I do. So you're driving your car at a speed of 69.5 miles per hour. What is this speed in feet per second? And I remind you here there are 5,280 feet in 1 mile. So the reason this one's more advanced, and we haven't seen one like this yet, is we're starting with and we're looking for a unit that is actually more than one unit. It's a combined unit where we're looking for feet per second. What is the speed in feet per second? So feet over seconds is what we're looking for. And we're also starting with a unit that's actually a derived unit of miles over hours or miles per hour. Notice how I have this written. I don't write this as mph. I don't write this as miles/hours all on top here. Even though those all mean the same thing, it's much easier to write it as I have written here, because this is what the speed of miles per hour means. We go 69.5 miles in every 1 hour, and so I can write it as you see there. So now I want to identify some equalities. Well, one of them we're given. There's 5,280 feet in 1 mile. So notice that should take care of this first conversion, going miles to feet. But then I also have to worry about hours to seconds. Well, ask yourself, what are the relationships there, hours to seconds, and what would I write there for an equality? Well, we know there's 60 minutes equal to 1 hour, so I can write that. So that would get rid of hours for me, but then I still need to get to seconds. Well, there's 60 seconds in 1 minute. So if I use those equalities, I should be able to do this. So thinking about how this is going to work, it does not matter which of these units, the miles or the hours, it does not matter which one you cancel first. You can do it in any order you want. Just because it was the first equality that I wrote up here, I'm going to use that one first. So I'm going to cancel my miles by putting 1 mile on bottom and 5,280 feet on top. Notice miles cancel. And notice, as far as my numerator is concerned, my units match. I'm looking for feet in the numerator. I now have feet in the numerator, so I'm done with that part. Now, I'm not done with the problem yet, because I still need to get to seconds in the denominator. What I don't need to do is I don't need to plug this in my calculator at this point and get an answer and then use that for a second problem. I can just keep going here all with one long string of conversion factors. So now I need to cancel hours. So if I look at my equalities here, I'm going to use the one that has hours in it. I'm going to multiply by 1 hour over 60 minutes. Now you might be thinking, wait, these don't cancel, they're not next to each other. The units cancel not because they're right next to each other. It's just about one being in the numerator, one being in the denominator. So this hours unit here that we started with is in the denominator. This one's in the numerator. They cancel. And now I need to cancel my minutes unit. So I can multiply by 1 minute over 60 seconds from my last equality here. Notice my minute units cancel. And now if I look at the units I have, I'm looking for seconds in the denominator, and that is exactly what I have now. And notice I have feet per second left over, so I'm done with the problem. Just a matter of plugging it in the calculator and getting an answer. And I get 102 feet per second. So looking at our standards and learning targets here, we're working on using proportional reasoning through the use of dimensional analysis. And in this particular lesson, we described conversion factors, and we looked at how we use those to convert units, and also how we use dimensional analysis to solve problems. In our next lesson, we will look at this same idea, continuing to use dimensional analysis, but specifically using the prefixes of the SI system, things like kilo and milli and centi, things you're already somewhat familiar with, and we'll look at how we employ those with our dimensional analysis.